Here we have the most visible part of our experiment, the tanks. The tank over on the left side here that has all of the little yellowy orange things, that is the tank that we are going to be performing our analysis on. And this other tank here just serves as the reservoir tank, so we can drain fluid from our primary tank into the reservoir tank. This is so we can test our method of measuring fluid volumes. The way we're going to do this is using PZT technology. PZT stands for piezoelectric transducer. The PZT actuator down here turns electrical signals into vibrational pulses. We're going to use this to ring our tank. So we're going to be sending different sound waves through the tank, and we can detect those with the other sensors in order to get our data and determine how much fluid is in the tank. This is the part of our experiment that doesn't look as big and fancy as the tanks, but we can still, this is where the magic happens. So we have our computer here. This is how we generate data and then collect our data. So the laptop sends a signal to this little box right here. This box collects all of our data that's generated and turns it into a form that the computer can use. So this graph right here is an example of what some of our data is going to look like. These peaks here give us an idea of how much fluid is present in the tank. When there are different fluid volumes in here, these peaks will actually move around, and by how much they move, we can tell the amount of fluid in the tank.
One of our goals at NASA is to be able to measure fluids in space when they're in a container. And up to now we haven't had a very good way to do that. So this experiment is adding to that knowledge.
I really hope that our experiment is going to go well. We're not sure how everything is going to respond inside of the tank, so it'll be really interesting to see how our data turns out after the flight.
We think the data looks very good, and therefore it would be easy to build a system around that data. It's very exciting to have a simple result in this field because there's many other people trying to measure the fluids under 0G.
It seemed to look really good. I know we were very concerned that it wouldn't act like it did in 1G, but it seemed to be promising. We got some very nice peaks, and they were shifting just like they should, and we were just very excited because it works.